So this question is also from the angular speed and displacement worksheet. This is from the back of the worksheet on angular speed. It is question number 5. So question number 5 says a water supply tunnel in New York is 1.7 times 10 to the power of 2 kilometers long and has a radius of 2 meters. If the beetle moves around the tunnel's perimeter with an average angular speed of 5.9 radians per second, how long will it take the beetle to travel a distance equal to the tunnel's length? Okay, so essentially, let's draw a picture. We've got a circular tunnel. Okay, we know the radius of the tunnel. And we've got a beetle that is moving around the edge of the tunnel. Okay, and we know that he is going to move a distance, which is our S value, okay, that is equal to the distance of the tunnel. Okay, we know the speed that he moves at, and we want to figure out how long, so what is the amount of time that it is going to take him to move this distance. Okay, so again, let's write down our variables by looking at the picture. So we have, or looking at the problem, sorry. So we've got our S, which is the distance that the beetle moves along the perimeter of the tunnel, and it is equal to the distance of the tunnel. So 1.70 times 10 to the power of 2 kilometers. Okay, now again, that distance is in kilometers. Okay, and the other distance that we've been given, which is the radius, is in meters. So the first thing that we're going to need to do is either convert the radius into kilometers or convert kilometers into meters, because we need both S and R to be the same units in order to get a ratio in radians for theta. So I'm going to take S and convert it to meters because that's the unit that we've been using as our standard unit for distance. So that's what I'm going to use. Okay, so 1.7 times 10 to the power of 2 kilometers, and I'm going to multiply it by a conversion factor with 10 to the power of 3 meters on the top and 1 kilometer on the bottom, which cancels out kilometers and leaves me with 1.7 times 10 to the power of 2 times 10 to the power of 3. Anytime I am multiplying two powers of the same value together, I can just add them. So 1.7 times 10 to the power of 2 times 10 to the power of 3 is just equal to 1.7 times 10 to the power of 5, because 2 plus 3 equals 5 meters. Okay, so that's my first variable that I've got, is the distance that the beetle moves around the edge of the tunnel. Okay, then I've also been given the radius of the tunnel, which is 2 meters. Okay, now that my distance around the perimeter of the tunnel is in meters, I don't need to convert that to anything because they're in the same units. So that is going to give me a theta in radians. Okay, then I've got the speed of the beetle, okay, which is 5.9 radians per second. And I'm being asked how long will it take the beetle to travel the tunnel's length. So I'm trying to find time. Okay, so we've been given a formula right now that includes time, okay, which is that the average speed, okay, or W of the beetle is equal to theta divided by time. So I just need to turn that formula around so that it's solving for time. So I'm going to multiply both sides by time, which gives me time times the speed is equal to theta. Okay, and then I'm going to divide both sides by W to give me time is equal to theta divided by W. Okay, now in order to solve for time here, I need to know theta, which is the angular displacement of the beetle during its movement, okay, and I need to know the average speed of the beetle. I know the average speed of the beetle, but I don't know theta. So the first thing that I need to do is figure out a formula for finding theta. And I can do that because I know that theta is equal to S divided by R. Okay, so now I can use the S, which is the perimeter that he traveled, divided by my R, which I've got, which will give me theta. Okay, then I take that whole number and I divide it by the average speed. Okay, and that is going to give me the time that it took. So essentially, I end up with 1.7 times 10 to the power of 5 divided by 2. Okay, and I take that entire thing and divide it by 5.9, which gives me an answer of 1.44 times 10 to the power of 4 seconds. Okay, hopefully that answers that question, and that is the answer for question number 5.